Now for this question 7, now just for a bit more clarity really, I can replace this this graph here, which is in your worksheet, with this just kind of a more colourly graph basically. And this is e of x, whereas you're meant to ask to plot then h of x, which is e to the power minus x. Okay, now it doesn't matter what graph you're ever asked to plot. If you're asked to plot a graph, you simply find a few values of x, sub them in, and they give you your y values. So look, it's between 0 and 1, so I'd be subbing in all of these values here. So that's h of 0 comes out as being 1, alright? Then everything else your calculator does for you. So you have all your inputs, outputs, inputs, outputs. That gives you your coordinates. So that helps you plot this graph then, okay? So you can see the shape of it there. There's a kind of a pattern going. It's kind of the inverse of this graph here, okay? So it looks like that. You can hide all the points then after that. So that's your graph drawing. Now part B then, so we want to find the area enclosed by this graph and the line x equals 0.75. Okay, so the first thing to spot is that the line x equals 0.75 is that. That's something a lot of people don't spot. That's actually the equation of that line. Okay, if it was y equals 2, we'll say, it will be that line there through 2. If it was x equals 1, it will be that line there vertically up through 1. Whereas if it's x equals 0.75, it's that line up through 0.75. And we want the area enclosed between that line and, so they're between the three of them. Okay, so this section here is what we're looking for. Now, how are we going to do that? So it's kind of an area question, right? So if we got the area of this red shaded part here, okay, then we got the area of this green shaded part here. And if we subtract one from the other, that's where we get the area between those two lines. So that's how this is going to work. So the first step here anyway is we need to get the area under the red curve here. And like this is, as everybody should know at this stage, this is the fundamental application of integration, is finding the area underneath the curve between two x values. So our two x values are 0 and 0.75. So that's what our definite integrals are going to be. Okay. Finding the integral then of e to the power of x is the easiest one there is, because that's one of the amazing things about the exponential function. It stays as e to the power of x. These are two definite integrals, so sub 0.75 in, sub 0 in, and we end up with 1.117. Your calculator will do that for you. Now we do the exact same thing with the green function here, so we want the area under the curve between there and there, so exact same thing. Now the only thing is when you're getting the integral of this, it comes out as minus e to the power of minus x, right? Because e to the power of minus x stays the exact same, but you're dividing by the derivative of minus x, which is minus 1, so that's where that comes from. You're dividing the whole thing by minus 1. Okay, sub in your values, and we end up with this. Now, final step then. So we know that to get this pink area here, it's going to be the red area minus the green area. So that's where we end up with that. So that's what we just do here. That, take that, gives you that. So that's the area of the pink curve here.